Okay, I tried on OneNote to do question one, and it was a bit, it didn't write everything in the screen. So, question one, part B, let's do it on the slides and see if it would be better. Question 1b says that let z be equal to x minus mu over sigma. Now it says that show that expectation of z is equal to 0 and variance of z is equal to 1. All right, so let's have a look what we have to do. We say that expectation of z here is equal to 1 over sigma expectation of x minus mu, because sigma is a constant. So that would be equal to 1 over sigma. Then we will have expectation of x minus mu, because mu is already a constant. So that one is equal to 1 over sigma, and expectation of x is equal to mu minus mu. This is equal to 0. Therefore, expectation of z equals to 0. Now, for variance of z, we put it as variance of x minus mu over sigma. So it would be variance of x over sigma minus mu over sigma. And that one would be equal to 1 over sigma squared. And variance of mu over sigma, this is a constant, is 0. So it becomes 1 over sigma squared variance of x, which is equal to variance of x is equal to sigma squared. So this becomes equal to sigma squared over sigma squared, which is equal to 1. All right, so this is question 1b. So let's do question 1c. Recall the definition of covariance in question 1c. The definition of covariance is in reading 5.1, and suppose that we have another random variable y, also assumed to have a mean and variance that exist. Show that covariance of a1 plus b1x and a2 plus b2y is equal to b1, b2 covariance of xy. The formula for covariance is covariance of xy is equal to expectation of x minus mu of x. Actually, it is times y minus mu of y. Expectation, instead of x, we have a1 plus b1x minus expectation of a1 plus b1x times a2 plus b2y minus expectation of a2 plus b2y. Expectation of a1 is just a1, and therefore a1 minus a1 cancels out. a2 minus expectation of a2 is just a2, they cancel out as well. So what we are remain with would be expectation of b1x minus b1 expectation of x times b2y minus b2 expectation of y. Now that is become equal to expectation of We multiply them by each other. So it becomes b1, b2, xy minus b1, b2, x times expectation of y minus b1, b2, y times expectation of x plus b1, b2, expectation of x times expectation of y. It becomes equal to expectation of x times y minus expectation of y minus, if we just rearrange them, expectation of x times y minus expectation of y. Now we can write that one as equal to b1, b2, expectation of x minus expectation of x and times y minus expectation of y, which is b1, b2 covariance of xy. Okay, now let's do question 2. It says that in readings 5.2, we introduced the Bernoulli and binomial distributions. Consider an experiment which can result either in a 1 or 0, with a probability of success between 0 and 1. All right, so then we say X has a Bernoulli distribution with a probability success of P, and mass function has the probability of X is equal to 0. Probability of X is equal to 0 is equal to 1 minus P, and probability of X is equal to 1, probability of success is equal to P. Now, in question 2, it says for X, part A says show that expectation of X is equal to P. We want to show that one. Now, we have got these two facts, yeah? Now, in order to say that, we know that for discrete random variable, expectation of X is equal to the sum of Xi times probability of X is equal to Xi. All right. Now here we have got X0 times 1 minus P plus 1, probability of X is equal to 1 times P. And that will give me equals to P. So expectation of X is equal to P. For part B, it says that show that variance of X is equal to P times 1 minus P. So the formula for the variance was what? Variance of X is equal to sum of xi squared times probability of X is equal to xi minus mu squared. So for that one, we have X only can be 1 and 0. So it's equal to 1 squared is equal to just 1 times P, okay, plus 0 squared times 1 minus P. And that one minus, we knew that the expectation, it means mu squared, expectation of X is equal to P, yeah? So it becomes P squared. So that is equal to 1 times P is equal to P minus 0 minus P squared. That is equal to P times 1 minus P. That would be the variance because it's P minus P squared. All right. So let's do question number 3, lab 5. Question number 3 says, for y this is distributed in a binomially with the parameters n sample size and p probability of success. Use the fact that y is the sum of n independent Bernoulli trials. Y is equal to x1 plus x2 plus x3, because we know a binomial distribution is the sum of the Bernoulli trial. Now, what would be part A? Question says, show that expectation of y is equal to n times p. All right. So we say that expectation of y is equal to expectation, we say it's sum of x, sum of xi, I from 1 to n. So that is equal to the sum of expectation of xi. All right? I is equal to 1 to n. So that is equal to the sum of the first one. Expectation is probability of success p I, let's say, because all of them are p. So in the other words, they're all equal to p, and I is equal to 1 and n. So that means n times p, because p with probability of success is the same for all of them, because we know that expectation of xi is equal to p. All right, part B. Show that variance of y is equal to n times p times 1 minus p. So we know from reading 5.1 that the variance of sum of xi is equal to sum of the variance of xi. Now, variance of y is equal to variance of sum of xi is equal to the sum of variance of xi, and we know that the variance of xy was p times 1 minus p, and it is n of them. I is equal to 1 to n. So it becomes n times p times 1 minus p. Okay, so let's do question number part C. Okay, question 3, part C. Suppose that n is equal to 10 and probability of success is equal to 0.2. Part 1 says, what is the expectation of y? We said that expectation of y was equal to n times p. N is 10 times p is 0.2. So expectation of y is equal to 2. Now, variance of y is equal to n times p times 1 minus p, becomes 10 times 0.2 times 0.8, which is equal to 1.6. What does part 2 say? It says that what is the probability of y less than or equal to 1? So probability of y less than or equal to 1 means that probability of y equals to 1 plus probability of y equals to 0. Now, based on the formula, probability of y equals to 1, we can write it as, okay, there are 10 trials, I have better write it for you here. We say that we have the formula for binomial probability of x is equal to xi in binomial distribution is n choose x, probability of success to the power x times probability of failure to the power n minus x. All right? So you can write this one. N is 10, x is 1, probability of success is 0.2, and then to the power of 1. Probability of failure is 0.8, that to the power 10 minus 1 is 9, plus. Then here, probability of y is equal to 0, n is 10, choose 0. Probability of success times to the power of 0 times probability of failure to the power 10 minus 0 is 10. Now here we know that n choose x is n factorial over x factorial times n minus x factorial. So here we have it as 10 factorial over 1 factorial times 9 factorial times 0.2 times 0.8 to the power 9 plus 10 factorial over 0 factorial times 10 factorial. Now here you can see that this 10 factorial can be written as 10 times 9 factorial, right? And then 9 factorial will be cancelled with this 9 factorial. So what, okay. And here we have got 10 factorial and 10 factorial, it becomes 1. 0 factorial is always equals to 1. 0.2 to the power 0 is equal to 1, and then times 0.8 to the power 10. All right? So that will give us equal to 10 times 0.2 times 0.134 plus the other one is 1 times 0.8 to the power 10, which is 0.1073, which give us 0.376. If you wanted to do it on R, in R, probability of y less than or equal to 1 in R, because we have binomial distribution, you can just write it as, actually I better do it with a different kind. P, no. Okay, it becomes P binom and then you will have 1 probability of y less than or equal to 1, and then n is 10 and the probability of success is 0.2. All right, so you know how to write it in R as well. Okay, now the last part says that part 3 of question 3. It says that what's the probability of y greater than 1? So probability of y greater than 1 would be 1 minus probability of y less than or equal to 1. The distribution, probability of y greater than 1, let's say this is 1. So we are talking about all these. Yeah, it is 1 the whole lot minus this area. Okay, but because it's a discrete random variables, it's important to have the less than or equal to sign. So that value is equal to 1 minus 0.376 is equal to 0.624. So please make sure that you are practicing with R and get probability of y less than or equal to 1 using R. Use R. And make sure that you understand it and you can do it. Okay, so we finish for this video until question 4, and we continue with the next question in the next video. Thank you.